So we have a work problem. A work problem is almost always set up the same way, where we're going to have a rate times time equals how much work is performed. So we need a, ooh, that's probably too far. Good. Good. Good enough. All right, so work problems are rate, the speed at which you work, times the amount of time you work equals how much work is done. Well, we have two pipes, so let's call them pipe 1 and pipe 2. Well, they say one pipe can fill the pool 1.25 times as fast as the second pipe. So if the second pipe goes at X pools per hour, then the rate to that one would be 1.25 X. Then we go on to say when both pipes are open, they can fill a pool in 5 hours. That means each of them, if they have 5 hours to work, they'll fill an entire pool together. So our time in this one is going to be 5 for both of them. So our amount of work that each one's completing to fill a pool would be, this one would be 5 times 1.25. Well, that's 5 plus 5 quarters. So that's going to be 6.25. And the other one's going to be 6.25x, and the other one's going to be 5x. So this says when they spend this much time working, they fill up one pool. So, in other words, the amount of work that pipe 1 does, plus the amount of work that this pipe does in 5 hours, will equal one full pool. Well, if I add these together, we're going to have 11.25x equals 1. So our x will equal 1 over 11.25. Now, let's look where that x would go in. That x would go in the rate of pipe 2, the slower pipe. So the slower pipe can fill up one pool per 11.25 hours. So it's going to take for the slower one 11.25 hours to fill a pool all by itself. Bless you. I think this is a good one to look at that you got Ross. This is a good one to think about. I'm not going to scan. You're good. This is a good one to think about. Just fill in what the table gives you and think about what it means. So they gave me the rates and they gave me a time. So fill in the time and the rates and work your whole table over. Then think about what it means. All right, so take the information given to you. In a work problem, if they give you time, they give you a rate, plug it all in, and see what you get. Don't just sit there and think about, okay, should the time or is it total? It is always going to be rate times time equals work. Fill in your table and go from there. And why I say that is because if you have your table filled out and you do some kind of work on the test, you'll get almost all your points. All right, as long as you can fill out a table and kind of interpret what's happening, you will get most of your points. You get your full points if you get it right. But if you are just, missing everything in your table and you have no work, that's when you get no points. So make a table, fill it out as best you can. All right, that being said, what questions do we have from the homework? The one with the big rig. Okay, let's talk about the one with the big rig.
Can you talk about both?
No. No, that seems too hard.
That's fine.
That seems way too hard for me to do. Okay, there's actually two ways to do. There's two ways to do the. Jason drove his rig across the United States of America. But let's just go with filling out a table. So we got ourselves a table. We know it's distance equals rate times time, so I need a distance. This will be that's too far for that. So we need a distance. Why won't that stay where I want it? Good enough. All right, so we're going to have a distance. We're going to have a rate. Actually, I'm going to put it in the other direction. We'll have a rate times time equals distance. All right, rate times time equals distance. Now, it goes on to say that he's making a trip, one long trip, and he stops about halfway. So Jason drove his big rig from San Antonio to El Paso, and he stops halfway. So that means we're going to have San Antonio to some kind of halfway point, and then we'll have that halfway point to the rest. So that would be El Paso. All right. So we have, at the halfway point, he notices that he has been averaging 80 miles per hour. So from San Antonio to the halfway point, he's been averaging 80 miles per hour. His company says that he only can drive 60 miles per hour over the whole trip. That's where I knew I needed a total row. So this needs to become 60 miles per hour. How fast does he have to go from the halfway point to El Paso? So that's all the information they gave us. But what we also know is if this is the halfway point, I don't know the distance, so I'll put that as x. If that's x, how far is it from the halfway point to El Paso? Yeah, x as well. Which means our total distance would be 2x. Now, I could figure out this time using our equation. Because this is 80. So anytime I have two things in here, we have 80 times t equals x. So time is going to equal x over 80. So this is x over 80. Well, the problem is I have two missing things here. If I have two completely blank things, there's no way I can really write an equation to match all three of these. So I need to pick a new variable. I have to pick a new variable. So I'm going to pick my variable for my rate. So I'll pick y, which will make my time x over y. And our total time would be x over 80 plus x over y. All right, well, this leads us to this equation down here, where 60 times all that needs to equal 2x. So we are going to have 60 times x over 80 plus x over y equals 2x. I guess I'll distribute the 60 first of all. So we'll have 60 x over 80 plus 60x over y equals 2x. Now I need to multiply both sides by 80y to get rid of those denominators. So I'm going to multiply both sides by 80y. So our first one's going to become 60xy plus, well, that's going to be 8 times 6 would be, okay, 48. So we have 4,800. The y's would cancel out, so I have 4,800 just x. And then we'd have 160xy. Okay, well, the xy's we can get on one side. So let's subtract 60xy from both sides and subtract that 4,800 from both sides. Actually, let's go the opposite direction. It's one less. So we're going to have negative 100xy plus that 4,800x equals 0. Well, at this stage, I could divide everything by 100. I could divide everything by 100. I'm actually going to divide everything by a negative 100. I like when there's a positive up front. So that's going to give me positive xy minus, mark that down 2, so we'll have minus 48x. Ooh, almost forgot the x. I'm running out of room, so I'm going to bump this up. Oh, that's too much stuff going on, but oh well. All right, so we have xy minus 48x equals 0. Well, since I have two x's, I'm going to factor an x out. So that's going to give me x times y minus 48 equals 0. Well, this is a zero product property. Either my x is 0. Well, if my x is 0, that means my distance is 0, which doesn't make any sense, so that doesn't work. The other option is my y equals 48. Y equals 48. Now let's look at, if y equals 48, what does that mean to the problem? Well, 48 would be the rate I would go from the halfway to El Paso, so 48 is actually my answer. It's 48 miles per hour. All right, so this is one of those rare cases where you do have to have two variables. Yeah, Mark?
The next one.
Okay, I'm just going to take a picture of the next one. That is just a work problem where you have Billy and Bob painting a house. It says that Billy can paint a house in 12 hours, and Bob can paint a house in 8 hours, I believe.
Do you have to create like another section, or just Billy?
Just Billy and Bob. So you need a Billy row and you need a Bob row. Well, Billy can paint one house in 12 hours, so his speed is one house per 12 hours. Bob is one house per 8 hours. How long does it take the two painters that paint the house? They're both painting the same amount of time, so they're both going to be time x. So the amount of work Billy will do over the entire period will be 1/2 times x, depending on our time, and Bob's going to be 1/8 times x equals 1/8 x. Now, when you take your works, so when you add up how much Billy does plus how much Bob does, that's going to equal 2 houses, because they want to know how long it's going to take to do 2 houses. So we're going to have 1/12 x plus 1/8 x equals 2 for 2 houses. All right, other questions from the homework? Yeah.
I have a question. Why can't you just add 12 and 8 if they're doing two? If one can do a house in 8 hours and one can do a house in 12 hours.
So if I
are they like working on one house together and then the next house together?
It really doesn't matter, because yes, it's not one person working on one house and one person working on. They're working as a team.
Mm.
So the person that paints 1/8 is going to speed up the person that's doing 1/12. Because you work with someone that's going faster, you're going to finish the job faster. It's not like Billy's going to paint for 12 hours, Bob's going to paint for 8 hours, and he's just going to watch Billy finish his house.
Okay.
Yeah, they're working together. That's why you can't just add it and say, oh, it's 20 hours because Bob's a jerk. That'd be an interesting answer on a test, though. Bob's a jerk, so it took him 20 hours. All right. Now that I said that, I wouldn't accept that as an answer. But I just contemplating if I saw that on a test. I'd be like, that's clever. All right. Other questions, though? Okay. Then today we're going to talk about circles. Yay. There we go. A circle. A circle is a set of all points in a plane that are equidistant, called our radius, from any given point from the center. So that's how a circle is created. You have a center, and you go out a certain distance, and you draw your finger around. That's how a circle is defined. That distance from the center to the outside is your radius. The distance all the way across is called our diameter, and the total distance around the circle is called our circumference. Most of that I really don't care about, but that's what a circle is. All right. Since a circle is just a set of points a certain distance away from one point, it makes sense that the formula to make a circle would be based upon the distance formula. And just to remind, our distance formula is take your x values, subtract them, square them, plus your y values, add them and square them, or subtract them and square them, and add those two things together, and then take a square root. So that's exactly what we're going to do here. We're going to come up with the distance formula from here to here to come up with our r value. So in this case, our r value is going to equal the square root of the distance between the center and that point xy. y. So we're going to call this point xy our x sub 2. And we're going to call this one our x sub 1 and y sub 1. So once again, think of this as being our first point, x sub 1, y sub 1. And these are going to take the place of our x sub 2, y sub 2. So our radius is going to equal the distance between those 2 points. Well, our x sub 2 is just x, minus our x sub 1 is that h squared, plus our y minus our k squared. So that's the distance from hk to a point on the circle. Yeah, I just picked these to be the names of these. These are what traditionally...
Isn't it just the same formula as right there? It's off the thing?
Yeah.
Okay.
Yeah, it's just a distance formula. Just the distance formula that we worked on, not yesterday, but the day before. Was it yesterday? Did we do the distance formula yesterday? It was the day before. Same thing we did the day before. Like pretend, so with circles, we always call this hk. For whatever reason, we call this center hk, but you could call it x sub 1 and y sub 1. It's just a point. This is just a point. I want to know what's the distance between these 2 points. So if I put a 1 and a 2 here, and I put a 6 and a 7 in here, I can plug it in and get that distance. So that right there is the distance of our radius. Well, that's also our formula for a circle. That is the formula for a circle. Most of the time you square both sides. You'll most likely see it like this. R squared equals the x minus h squared plus y minus k squared. But it really is just the distance. What's the distance between a point and another point? That is your formula for your circle. Now, most of the time we will know these numbers, and these numbers are what's going to get filled in to finish off our equation. So most of the time we'll know h and k. Yeah?
That's to find the radius, though.
It is, but it's to find every radius. It's kind of like a line. When I come up with an equation, y equals 2x plus 3, I'm finding a whole bunch of different points. So like I said, this h and k will usually have values attached to them. So it'd be like 2 and 3, and these x and y's will be variables that you can plug in, just with a line. Y equals 3x plus 2. Your x and y stay open to plug numbers in.
Why isn't it called the radius formula?
I don't know.
I just thought there was a reason.
There's no reason. It's because it forms a circle, so they're going to call it the circle formula. A radius formula sounds kind of funny because it makes it sound like you're just making one radius. You're actually finding every radius around here, so you're making every one of these points. So if you want to think of it as the radius formula, if it helps you remember it, then do it. Just when you get to college, don't tell everyone it's the radius formula when a professor shows you, oh, that's the radius formula. My math teacher told me it's the radius formula. All right, so that is our formula for a circle. It's just x minus h squared plus y minus k squared, and we have r squared there. So just remember your x value is affected by your first, y is your second one. And I do have the formula down there as well. So taking that into account, we're supposed to graph this circle. We're supposed to graph the circle that's x minus 1 squared plus y plus 2 squared equals 9. Now remember, our formula is x minus h squared plus y minus k squared equals r squared. Remembering that affects how this is going to play out. So just a reminder, this h is going to be your x value of your center. This k is going to be the y value of your center. So your h and k is your center of your circle. So this 1 and 2 are what's going to cause you to have a center of a circle. But just like everything with parentheses, like remember when we were graphing like sine and cosine, anything that was in the parentheses, it went the opposite direction. Like if it was positive, it went left. If it was negative, it went right. Same thing here. They're kind of the opposite of what you're thinking of. Since these need to be negatives, since this is a -1, this is going to give you the point +1. And since this is a +2, it's actually going to become a -2 in the point, and that's because it comes from this negative value here. This is actually y minus a -2. That is y minus a -2. In other words, if it's in parentheses, it's just the opposite of what you think it should be. In fact, this is the value that makes this 0. If I plug a 1 in, 1 minus 1 is 0. When I plug a -2 in, -2 plus 2 is a 0. These are the values that make it 0. Well, since we have our 1 and our -2, that's going to be the center of our circle. 1, -2 is the center of our circle. All right, the next point we need to have is this, that 9 is in place of the r squared. So in this case, r squared equals 9. So it's not our radius. 9 is not our radius. 9 is our radius squared, so you have to take the square root to get r equals 3. It will always be positive. We're not going to do positive, negative. So our r equals 3. Our center is 2, 1. That's all the information we need. Now all we're going to do to come up with the radius, I'm not looking for crazy good drawings on your homework. I just want you to kind of count up 1, 2, 3, put a point. All right, and that is because our radius is 3. Then we'll count left 3, 1, 2, 3. Then we'll count down 3, count right 3, and we'll go and have a perfectly drawn circle with no point at the top at all. Was yours better?
No,
Oh.
it's terrible. I mean,
I'm terrible at circles. It's probably better than mine, though. Mine has a point at the top. Okay, that's how you graph it if I give you the equation. Your big thing is to keep track of the fact that if it's positive in here, it's actually negative. It's what makes it 0. If it's negative, it's actually positive for your center of your circle. All right, next example. Write the standard equation for the circle. Well, our standard equation for a circle is r squared equals x minus h squared plus y minus k squared. So we have r squared equals x minus h squared plus y minus k squared. Well, the h and k are in place of our center of our circle. So the h is actually -3. The k is 5. These are always the easy ones to get. So we're going to have r squared equals x minus a -3. So it's going to become a positive 3 in just a second. Plus y minus our k. Our k is 5 squared. Your h and k should be the easy ones to get. The hard one is your radius. In order to get your radius is a distance from this point to a point on the circle. I was nice enough to give you a point. Sometimes you actually have to just pick a point that's on the circle that you can see easily. But this case, we have this 1/8. So our r value is going to be this distance. R is that distance. It's the distance between point -3,5 and 1/8. So we're going to have to come up with a distance formula. So r is going to equal the distance between -3,5 and 1/8. Well, our distance formula, once again, is our two x values subtracted and squared. So 1 minus a -3 squared. And we're going to add our two y values subtracted and squared. So that'll be 8 minus 5 squared. Let's run that down. We're going to have 1 plus 3, so that's going to be 4 squared. Plus 8 minus 3, or 8 minus 5 would be 3 squared. That is 4 squared is 16, plus 9 would be square root of 25. That means our r equals 5. Our radius equals 5. So that means we're going to plug that 5 into here. Yeah. Oh, did I make a mistake somewhere? Yeah.
No, I just did it where you, on the top right, I just filled that in with the X and the Y. Does that work? Because I still got 5.
In the top right? Yeah.
Okay.
Are you saying you actually plug your X values in?
Like it's like the same formula. Kind of.
So you plug this 1 and 8 in.
Yeah.
Yeah, that will work too.
Okay.
So what Mike did is he plugged the 1 and 8 in. It has to work because that is a point. That's our center. So 1 and 8 will definitely work on there. Yeah, Russ.
Do you see like that it just goes, so it's up 5, it's like -3, 5.
Mm-hmm.
Then it touches like the axis.
Make sure you're 100% certain. So I'm not 1,000% certain because what if it gets really close, like 0.1? If I'd put a point on here, then you'd be like, okay, I know for a fact. So if you want to take that chance, you're running out of time, you're like, okay, it looks like it's 5. At least put an R and say it's 5. At least I know what you're thinking then, because we all know what we're looking for. And your way will work every single time. Yeah. All right. So that means we have 5. So we're going to plug a 5 in for that R. Well, 5 squared is actually 25 equals x plus 3 squared plus y minus 5 squared. So when you plugged in, you probably came out with the 25, right? Yep. All right, but that's our equation. Yeah, thanks. Not so bad, is it? It's just circles. Just circles. All right, h, k, and your r values are the big ones. All right, the hardest part about today is probably completing the square. If you're good at completing the square, this part will be easy. If you're not, then it's going to be slightly more difficult. You've never done this? All right, well, this will be fun. All right, this is the fact about completing a square, but I think it makes more sense when we actually do it in practice. All right, so we're supposed to complete the square, and then we're supposed to factor. When you complete the square, all we're trying to do is come up with something that's b divided by 2 squared. And I'll talk about why it's important in just a second. So we're going to do b minus 2 squared. So in this case, our b value is 6. So we are going to have 6 divided by 2 squared. Well, working down, we're going to have x squared plus 6x plus, that will be 3 squared. We're not going to finish the square, because the whole point of completing the square is something that's factorable. It is something that I can turn into a binomial squared. That's why it's called completing the square. So we are going to now write this in terms of a binomial squared. In order to do that, you're just going to take your first variable, which is our x, and you're going to take your second item, which is a positive 3, put them together, and then you're going to put a squared after it. So x squared plus 6x plus 6 over 2 squared is x plus 3 squared. It turns it into a binomial squared. The same thing's going to happen here. The reason why I picked this one in particular is our b is now a negative 5. Our b is a negative 5. So that means we are going to have a negative 5 divided by 2 squared. So it's just your b divided by 2 squared. Don't forget about your negatives, because it's going to turn it into this. We're going to take our x and plug it down here. And then we're going to take our negative 5 over 2 and plug it there and move our squared up there. So x squared minus 5x plus negative 5 over 2 squared becomes x minus 5 over 2 squared. Now, why is this important to circles? Well, if you were ever given x squared plus 6x plus y squared minus 5y equals negative 1/4, and I tell you to graph that, it's a really hard thing to graph because it's not in this form where I have my h and k values just standing out in front of me. So what we are going to do is we're going to complete the square for our x's, and we're going to complete the square for our y's. So that way I'll have a binomial squared plus a binomial squared equals something, and I'll have my r value, I will have my h value, and I will have my k value. So if we look at our x squared plus 6x, this is how I'd handle this. I go, okay, it's x squared plus 6x plus something for my x's to complete the square. And then we're going to have plus y squared minus 5y plus something is going to equal negative 1/4. Now, if I just add something to one side, is my equation balanced anymore? No, it's like if you're lifting weights and you have a bar and you just add 5 and then 5 more pounds on the left-hand side. You're off kilter. So if you're going to add something to one side, you have to add it to the other side. So the right side is going to be plus something to keep it balanced. So when we look at that x squared plus 6x, we are going to add in that blank 6 over 2 squared. And then I'm going to go to the right side and add that 6 over 2 squared to that side. Then we have to complete the square with the y. So we're going to have a negative 5 over 2 squared in that space. And we're going to do the same thing on the right side, and we're going to have negative 5 over 2 squared on that side. Now everything stayed balanced. I added 3 squared to one side, I added 3 squared to the other side. I added negative 5 over 2 squared to one side, I added it to the other side. So everything stayed balanced. Now my equation is the exact same. I can just write it slightly different. So that x squared plus 6x over 6 over 2, we can rewrite as x, just like we did above, plus 3 squared, plus, we take that y down, we take that negative 5 over 2 down, squared, and now we just have to deal with the other side. So we're going to have negative 1/4 plus, well, 6 over 2 squared is really 3 squared, so that's just plus 9. Negative 5 squared becomes negative 5 times negative 5. It's going to become a positive 25 over 4. Well, everything's over 4 except for that 9, so we have to put that 9 over 4. So what I'm going to do is I'm just going to say, well, this is going to equal negative 1 over 4 plus 36 over 4 plus 25 over 4, which is going to equal 36 plus 25, well, that's 50 plus 11, so that's 61, minus 1 is 60. Divided by 4, what's 60 divided by 4? Oof. I'll go with 15 on that one. So our equation is now x plus 3 squared plus y minus 5 over 2 squared equals 15. So now I have my h value is negative 3. So this is a circle centered at negative 3, positive 5 over 2 with a radius of square root of 15. That now it's actually doable to actually work with it. I know. You'd be surprised. This actually makes your life easier than if I would ask you to graph it in standard form without doing this. This is the easiest way to graph a circle if it's not in our normal circle form. All right, questions on any of that?
No.
All right, cool. All right, so that's circles. That is circles. Let's talk about what's upcoming. Tomorrow we're going to talk about standard form and point slope form of lines. Monday's review, Tuesday's test. So the hardest part in this section should probably be those word problems. The rest just involve practicing and memorizing equations. All right, we have the distance equation, we have the midpoint equation, we have slope-intercept form. We learned 2 ways to graph a line, but I don't really care which method you use. And then we'll talk about standard. So it's just a bunch of different equations that you have to keep in your mind. It's just practice. Minus the word problems can be tough. You can practice those a ton, you get to the test, and your brain goes blank. So that means you really have to focus on the stuff that's just rote memory. The ones that are just formulas that you're plugging stuff in. You really have to take your time on stuff like this so you know how to complete the square. All right.